Hello everyone, I am Prasad from Structural Guide. Today we are going to discuss about thick concrete or concreting of thick concrete or large volumes. In today's discussions we are discussing about what is this thick concrete is mean, mock-up testing, temperature control, how to finalize the formwork in thick concrete, curing, how to handle the curing, its design, etc. So there are many things to learn today. So you can wait till the end of this video. You will know a lot more. So without further taking time on this, let's start our discussion. What do you mean by thick concrete? What do you mean by thin concrete? Now, in thick concretes, in a way it's a large volume and also it has a thicker section. For example, now when you take a slab, generally floor slab, its thickness going to be around 125, maybe 150, 175, maybe 200 or 250. In a way, those kind of concrete we are called as a smaller concrete or thin concrete. There's no name called thin concrete, but for time being we consider as its thickness is less. But when it's come to the column, for example, comparatively columns are large elements. But those are not the thick concrete. We'll take a rough foundation having a thickness about 1000 millimeter. So 1000 millimeter is a kind of a thick concrete. In a high-rise building, 1500 millimeter thick concrete is a thick one. Their behavior or concreting work is not same as a sap concreting. There are similarities, but there are important facts that we need to consider during the construction. So I think now it's clear to you about the thick concrete. What is the thick concrete is? So before discussing about the how I handle the thick concrete, we need to know many facts about the thick concrete before moving to that. Right, mock-up test. What do you mean by mock-up test? As the name implies, mock-up test is a kind of test that is done before starting the concrete work. So when you want to do a thick concrete, like very large column, maybe the 1500 millimeter thick rough foundations. So in that case, we do not know the behavior of this concrete. What's its temperature rise? What kind of a curing method is need to implement? How do you plan the concreting? Do we need whether it is required to modify the mix design? All those we have to be known. So all those we can do with the mock-up test. All those things we can analyze with the mock-up test. So mock-up test is a kind of a test we do by matching a similar kind of element size to the size of concrete. That means if your column is 1500 by 1500, so we cast a 1000 millimeter or 1500 concrete cube. Then we can assess these parameters. So based on our element sizes, we can cast a cube like this, right? So we can cast a cube like this and we can monitor the temperature variation of this. Mostly these element sizes we try to match with our actual construction. The minimum would be 1000 millimeter, and it's basically what we do is the matching is the best, so we can get the end result correctly. So I think you now clear what's the mock-up test. In mock-up test we finalize all those things with design, curing method, formwork, what kind of a temperature we kept at the core. Now we as we all know, the core temperature of the concrete is very important to us, right? So this is our concrete. So we have a formwork in the sides, right? So this is a formwork. In our formwork here also we might have a similar kind of a thing, because when you do on the ground there may be a screed, so we have to match that also similar way. So this formwork, this is the concrete what we are going to do. Now what we are going to do is in this concreting is we first finalize the mix design, right? This mix design. We, for example, we know what kind of a concrete we are going to put in the concrete column. Say it's grade 40 concrete. So we are going to pour the grade 40 concrete to this mock-up test, this block. Now you know the element sizes, you know the grade of concrete. Now next thing is once you pour the concrete, we are going to monitor the temperature, right? We have to monitor the temperature. What we do is this variation of the temperature will be monitored, the core temperature and the surface. This is a cross section, right? This is a formwork here, so it's the top surface, right? Now we monitor the core temperature variation. Now the surface temperature also we can monitor. So once you monitor the core temperature and the surface temperature, we can calculate the temperature difference, temperature gradients, because in a large volume concreting we have to control the core temperature and the temperature gradient and the temperature difference. If I elaborate it little more, in general, as a general norm, we maintain the core temperature around 70 Celsius. That's because to allow to delayed ettringite formations. It's a kind of a different thing that we need to discuss. You may refer our videos, or you may go to our structuralguide.com website. There are more information about this delayed ettringite formation. In addition to that, we have to maintain this temperature difference here to there. Right? This difference we have to maintain. In addition, the temperature gradient. Gradient is the temperature difference divided by this distance. Right? This distance we have to divide by this gradient. So all those values we should maintain in the range of 20 to 25 Celsius. Right? This may be specified in your specification. You have to follow that. So anyway, you have to maintain those values. Right. Now I think it's clear to you what are the things we monitor in this mock-up test. So in addition to that, the actual formwork. Now what kind of formwork we are going to do is we have to use in this construction, because we can't use separate kind of a formwork to the mock-up test and for the construction. Okay, both should be similar. Actual condition has to be reflected in the mock-up test. So the formwork should be similar and the thickness of the formwork also has to be similar. So that we have to keep in mind. So now we have finalized the formwork. So your formwork is finalized, right? You know the monitoring temperature, right? Then the curing method. Now let's come to the curing. Now say you have poured the concrete to this block. So once you have to pour the concrete, before it getting dry in the surface and also before it getting the heater, we have to start the curing. Now actual condition and the mock-up condition should be similar. If I elaborate more on the curing, simply we have to control the core temperature, right? Temperature gradient, temperature difference we have to control by the curing, and also this surface condition we have to control by the curing. Right? That's what we basically do in the curing in the thick concretes. Alright. If you want more information, you may refer to our structuralguide.com website or videos we have shared in our channel. Right. Now I think it's clear to you what we do with the curing. So we have to finalize the curing method. Now in the thick concrete, we don't pour water in the top. Okay. That's because the water temperature will be vary, because with the environmental condition and that the water temperature will be vary. What we do is we have to apply a certain cover. This may be a soil layer, this may be a sand layer, this may be you can place a polythene on it and you can put the sand, soil or any other curing membrane also you can apply it, but we have to make sure the surface temperature does not vary with the ambient temperature. That you have to make sure, because temperature gradient, as I mentioned previously also, you have to make sure the temperature gradient is not varying significantly. Right. I think now up to that point it's all clear to you. Now we have considered what to do with the formwork in a thick concrete. Right now, let me elaborate on the temperature variations also. Now once you put the concrete in, the core temperature will rise, right? So this variation will be go like this within certain period, may- maybe 2 to 4 days or 2 to 3 days, the temperature will reach to the peak, right? This peak value we generally maintain around centigrade Celsius, 70 Celsius, or this 70 degrees, right? This has to be maintained. If you rise it now during the mock-up test, this may go like this, right? This may would have reached to 80, right? Let's say it's reached to 80 in the mock-up test. So what we need to do, right? As a general norm, as I said, we are maintaining the temperature at 70, so we have to lower it. What we can do, so we can do is the best thing we can do is the change the mix design. We can change the mix design and control it very easily. Now in a thick concrete like this, we use additives like 5S or silica fumo, GGBS, or those kind of additives we use in the concrete. Or the we use cement combination, not only the cement OPC, but we add the fly ash or any something like that to reduce the heat of hydration. Now the amount, say initial mix design, you might have used the 15% of fly ash, but it can be increased according to British standard. It can be increased 35%. So you might increase that to maximum level or any other required level to reduce this core temperature, because it's have a certain risk. So that kind of a thing we can do, and that is identified through this mock-up test. And also this temperature gradient, now if it is more than what we expect, so we can modify the formwork as well, because if you have a low temperature at this point, that does mean that your energy will be dissipating through this surface extensively. So if the surface temperature is very close to the ambient, then that is clear. Now you may need higher thick formwork. For example, if you are using plywood, you might need to increase the thickness of the plywood. That decision will be taken based on this result of the mock-up test. Right. Now, if there is a very large volume of concrete having a higher thickness, like 3000 millimeter thickness, 3 meter thick concrete we are pouring for a large area. In spillways like structures, very tall building, rough foundations or pile foundations, we might need this kind of a thick concrete. So how do you control this heat? Right, it is also kind of a curing method. What you can do is, if your heat is like reaching more than this or at this level, you may place the pipes. Now say this is your foundation, you can lay pipe in this, okay? So you can put water in from the pipe one side and you can remove the water. So by that you can extract the heat in the concrete through this pipe. So what we do is we send the water, then water absorb the heat, and the temperature going to be reduced here. So with that we can reach to a acceptable temperature level. So those are certain important facts about the thick concrete that we need to attend. So all those will come with the mock-up test. If you do the mock-up test, you can identify what happened in the actual concrete. So based on that, these preventive measures, this curing method or temporary reducing method, modify mix design, all those decisions can be taken. So therefore, when you do a large concrete, it would be advisable to do a mock-up test rather checking it during the actual construction. When you do the construction at site, or when you construct in the rock foundation also, this can be done. But rather monitoring at that level, it would be better if you can monitor it as a mock-up test. Right now, we were discussed about the method of finalizing formwork, concrete design, and curing procedures. In addition to that, when you do a very large concrete, maybe a very large one, right? So you may have to plan the concrete pours, because when it is a very large concrete, you might not be able to do whole concrete at once, because it will take weeks to complete, or it will take 2-3 days to complete the concrete work. So it's very difficult, right? Therefore you might divide this large concrete into several pours like this. So this sequence you have to plan, right? This sequence you have to plan. So you have to get the advice, and you have to think these boundary conditions, because there will always be the creep and sinkage and expansion, thermal expansion and thermal sinkage effects around these boundaries. So you have to think about all those when you're doing the concrete work. So adjoining ones, better do it later. So those things you have to consider when you plan in the concrete pouring sequence, or concrete pouring pattern. This kind of pattern you can plan for the thick concrete, very large concrete, so that you can handle the thermal issues as well, and also the construction issues, like you might not be able to pour very large concrete at once. So those things has to be, you'd be able. So you can chip this joint, and if required water bars and all this other requirement you can fulfill here to treat the joint, right? Now we know how to plan the construction sequence. The one of the other important thing is the resources planning. This one. Now we have to plan the resources before starting the construction. One such example is the batching plant. Say you can have a batching plant that can supply all the concrete required to this concrete pouring. That particular batching plant has the capacity. What if this batching plant break down? What we can do? We can't do nothing. We have to hold the concrete. So if you don't have such a plan, you will be in very deep trouble. So when you do this kind of very large concrete, you should always have a separate standby batching plant. Its need may not be operated, but you should have a standby one. Now when you're doing large concrete, you may have a separate batching plants. I mean, in addition to that separate batching plant, you may do the concrete with 2 batching plants, but better have a third one to maintain the required supply. Right? If you do with 4-5 batching plants, then this might not require, because then we have a standby batching plant. Of course, if you have a 3-4 batching plant, but if you do with 2 or 3, better have another one. Then you can maintain the supply, or you can do it as it is as planned. But in addition to that, you might have to plan the resources, metal, cement, all that you have to make sure are there. I think now we discuss about most of the things related to thick concrete, thick concreting works. You have to plan it, you have to monitor it, you have to make sure you are doing the construction is very correctly. All those things what we discussed today. So if I summarize what we discussed: mock-up test, temperature monitoring, finalizing formwork, finalizing curing method, modifying the mix design as required, right? Then resource planning and construction sequence planning you have to do when you do in the thick concrete or the very large concrete. I think you were able to get to know some important facts about thick concrete. Let's meet again from the new video. Please be with us. Thank you very much.